form. So I want to show you an example, okay? So first of all, as an example, if I had 3x times 2x plus 1. Okay, write that down, please. Okay, write that down, please.
Ring, ring.
Mr. Hoya, yes. Okay, she's not here.
Oh, yes, Spencer's here.
Sierra, she's on her way.
What's that?
Okay, thank you. Sierra, Mr. Hoya, I want to see you. Okay, so, you ready? Did you ever write this example down?
Yeah.
Now, you guys watching? Now, what we could do is we could distribute, and of course, everybody knows that x times x is what? One more time, x times x is what? So I get a 6x squared plus a 3x, right? Everybody agree with that? So when we talk about factored form, we want to be able to take the 6x squared plus 3x, and we want to write it kind of like that before it was factored, okay? This is factored form, so we want to write it before it got distributed. So this is factored form. So we already know the answer because we made it from this. So the answer to this being factored is this. So here's how factoring works. I asked myself, what is the biggest number that divides into both of these? What is the biggest number that divides into both of these, right? Okay, 3. Everybody agree? 3 divides into 6, and 3 divides into 3. So they have a common factor of 3. So I write down there common factor of 3, okay? So this is called factoring. We say to ourselves, okay, what's the biggest number that divides into both these? Okay, so they have a common factor or a common 3. Now, here's another one. They both have x's, don't they? So how many do they both at least have in common? They both have 1x in common, right? So I can take out their 1x, right? Did you guys do this in algebra? Maybe? Okay. So we can common factor out there. So this is their common factor. They both have a 3x in common. Both terms have a 3x in common. So if I divide out the 3x, I'd have a 2. If I took out the x, I'd have an x left over. And we're going to practice this more. 3 goes into 3 one time, and I took out the x. Now we're going to practice. This is factored form. So the factored form is when you find out what they have in common, okay? So we're asking ourselves, what do all terms have in common, okay? What do all terms have in common? That's what we're looking for, right? Okay, what do all terms have in common? Okay, so then, in this case, one more time, they both had a multiple of 3 in common. They both had a multiple of 3 in common. They both have at least an x in common. You guys see that? Okay, now, let's keep going. Zero product. Zero product is, well, anytime you multiply by 0, you get 0, right? You guys agree with that? So zero product. So if I had 3 times 2 times 0, I already know the answer. What's the answer? 0, right? Or if I had 3 times 0 times 5, the answer is what?
0.
Yeah.
Or if I had 0 times 2 times 5, the answer is what?
0.
So it doesn't matter. As long as one of the answers is a 0, the whole thing's 0, right? Does that make sense? If one of the numbers is 0, so if you got 0 times any of those things, as long as one of the numbers, those are zeros, okay? So what is a 0? Well, zeros are roots. Roots are going to be your zeros. And we're going to write down specifically any, write this down, any value that makes the equation 0 is a 0, okay? Now we're going to hang on to that information, and we're going to take a look at some examples here in a second, okay? Any value that makes the equation 0 is a 0, okay? Any value that makes the equation 0 is a 0, okay? All right, now shift over to example 1, okay? Write that down. We're going to shift over to example 1, okay? Okay, shift over Okay, guys, ready to shift over to example 1? Okay, let's look at example 1, okay? Now, let's take a look at this. We want to find the value of x. We want to find the value of x that makes it 0, okay? Well, let's do the easy one first. Look right here. If x were negative 5, just think about it. If x were negative 5, think about it. What's negative 5 plus 5? 0. You guys agree with that? So negative 5 has to be a 0, right? So, and what if x were 0 here? If x were just plain old 0, throw in 0, then that would make the whole thing 0 also, right? Now, if you have a hard time doing this in your head, what we can do is this. I know, first of all, we're going to have 2 answers. We're going to have 2 answers, okay? We're going to have 2 answers, right? Because there's 2 x's. You guys agree with that? 2 answers, 2 x's. So what I like to do is I like to teach, okay, if there's 2 answers, make 2, I call them mini equations, okay? Now, if you can do these in your head, awesome, okay? If you can do these in your head, awesome. Boys, stop talking, okay? If you can do these in your head, awesome. But if you can't do it in your head, we're going to do mini equations, all right? So I've got 2 x's. Let's make 2 equations. One equation is right here, x equals 0, and the other mini equation is right here, x plus 5 equals 0, okay? So I make 2 mini equations. This is already in factored form. I'll keep saying that as I do this lesson. Okay, and then solve for x. Well, solve for x. Now, mini equations and solve for x. Well, this is easy. This one's already solved for, isn't it? X equals 0. Boom. It's done, right? Solve for x. X equals 0. Boom. Circled. That one's done. That's one of my zeros. How about this one? Well, you guys know how to solve for this, right? What do we do to solve for x? It's minus 5, right? Minus 5, minus 5. X equals negative 5. That's the other 0. 2 answers, right? 2 answers. Always 2 answers in these, okay? There's 2 x's, 2 answers, okay? All right, let's shift over and look at example 3, okay? So example 3, here's what I told you. I said, first of all, let's make 2 answers, right? So let's make 2 mini equations, okay? So we're going to do 2 mini, so I do mini equations. I'm doing my mini equations, all right? My mini equations, so I'm going to go, all right, 5p equals 0, and p minus 2 equals 0, okay? 2 little mini equations, right? Just set them up. I know I'm going to have 2 answers, 2 little mini equations, 5p equals 0, and p minus 2 equals 0, okay? So far, so good. And then solve. So to solve for this one, we'll divide by 5, right? Divide by 5. 0 divided by 5 is 0. There's one answer, right? That was easy, right? Other equation, super easy, right? Plus 2 plus 2 plus 2 plus 2, p equals 2. I have 2 answers, 0, and 2 are my zeros, okay? Thumbs up so far? Does this seem pretty easy? I'm hoping it is. Hoping this is one of the easiest days you've had, right? Okay, how about example 4? 2 answers, right? There's 2 C's, so there's 2 answers. So let's make our mini equations. Okay, our mini equations, we're going to go C minus 2 equals 0. And let's go C plus 1 equals 0. Okay. And we'll just solve, right? Am I going too fast? Am I okay? Okay, so if I want to solve my first equation, plus 2, right? We agree, plus 2, plus 2. My first mini equation is 2, right? Minus 1, C equals negative 1. Boom, easy? You guys agree? Super easy. Anybody having troubles with this? I didn't think so. It's easy, right? Okay, example 6. Let's shift to example 6, okay? All right. How many answers? How many answers? 2, right? Because there's 2 S's, right? So let's make our mini equations again. Let's make our mini equations. We're going to go 3 minus 5s equals 0 and minus 3 plus 5s equals 0. Okay, mini equations, right? Okay. So, what are we going to do? Well, we're going to solve this, right? Minus 3, minus 3. You okay with that? So I get a negative 5s equals negative 3. Am I going too fast? Am I okay? Okay, divide by negative 5 And you could either give me a decimal answer, which will work, 0.6, or I just like the fractions. Fractions fine. How about positive 3/5? Because negative divided by negative. Or if you want to use a decimal, use a calculator. If you want to use a calculator, get 0.6. I'm okay with the calculator answer, right? If you go 3 divided by 5, 0.6, okay? But we got to get the other answer. So let's get this answer, right? So let's go plus 3, 5s equals 3, right? Divide by 3, divide by 3. 3/5 is a great answer, or 0.6 if you use a calculator. So you get s equals 3/5, okay? Circle that answer, okay? All right, that is what we call a repeated root. That's a repeated root. So let's go back, and you don't have to write this down, but check it out. Here, this one, I didn't answer this, right? So repeated root. In your words, what's a repeated root? Same answer, right? Same answer twice. It's just the same answer twice. And sometimes it could even be 3 times. But, you know, so you get the same answer twice. We still got 2 answers, even though it's the same answer twice. So it's kind of a trick question to say 2 answers, because it's really what I got was, I got 3/5, I got 3/5. So Bella's going to say, no, Mr. Davies, that's only 1 answer. I would agree. But we're going to count it twice. But why count it twice? It's just the same number twice, right? Okay. Now, 7. 7's a little bit tricky, but we're going to rewrite it as x minus 3, x minus 3, right? Right? Because something squared is itself times itself, right? Something squared means itself times self. Okay, well, this is easy. Many equations. X minus 3 equals 0, and x minus 3 equals 0. Well, that's pretty easy, right? You guys agree? X equals what? 3. Everybody can do this in their head, hopefully. 3 twice, right? That's a repeated root. So x equals 3. How about I just write it down once? Same answer twice. You guys okay with that? Let's just write it down once, okay? All right, now let's shift down to 11, all right? Let's take a look at 11. Am I okay on my pacing? If I get going too fast, will you tell me, please? Okay, let's look at 11. Okay, now, 11. How many answers? 3. There's going to be 3 answers. How do we know there's 3 answers? There's 3 G's. G here, there's 1 answer. G here, and G here. So this one's going to have 3 answers, right? Everybody agree with that? Okay, so again, let's do our mini equations. We're going to have 3 mini equations, right? One mini equation is just simply G equals 0, okay? Because I got G equals 0. That one's done. You guys agree? Solve, boom. I'm going to circle that one because that one's finished, right? Second mini equation is 6 minus 3G equals 0. And my other mini equation is 6 plus 3G equals 0, okay? So, I've got 1 answer, right? And I wrote my mini equations because my mini equations help me solve it. So let's go. God bless you. Minus 6, right? If we're going to solve it, minus 6, negative 3G equals negative 6, right? Divide by negative 3, G equals 2. Because negative divided by negative 5. Okay, so we got 2 answers, right? Got 2 answers. Okay, let's get the third answer. Am I okay so far? Minus 6, right? I'm going to have a 3G equals negative 6, right? Divide by 3, right? And I get G equals negative 2. So I got 3 answers, didn't I? I got 0, 2, and negative 2, okay? Thumbs up? Thumbs up, so far so good? Okay, now, here comes the part when we flip the page where we're going to have to think, okay? We're going to have to factor. So what I like, before I go on, I'm not going to turn the page. I really like it in this form because the mini equations are easy, right? But if it's not in factored form, we need to put it in factored form. And that's going to be the part that I'm probably going to have to spend a good 10 minutes teaching you how to factor. Okay, so, ready to turn the page? Some of you know how to factor, don't you? Right? Some of you know how to factor. Okay, here we go. Let's look at number 13, okay? I want I want mini equations. I liked it in mini equations, right? So what I want to do is factor, okay? So if I take a look at 13, we're going to factor. So, I need to factor. And here's what we're going to do. We're going to do what we call common factoring. What do they have in common? I got two terms. What do they have in common? So they got an x in common, totally agree. So they got an x, let's write it down. They have an x in common, totally agree. Okay? And they actually have a little bit more than x. They also both have a multiple of 3 in common. Do you guys see that? They have an x in common, so I write it down, and they both have a multiple of 3 in common, okay? So start right there. So when you common factor, we're trying to make mini equations. Yeah?
That's the exact same one that you did as your example.
What do you know? What do you know? There is some method to my insanity, huh? Tim, who would have ever guessed that I would do something like that, huh? So, if I divide out a 3, I'd get a 2, right? And if I pulled out an x, I'd have an x left over. I'll say it again. This is the tricky part. I divided out a 3, so I'd have a 2 left over, and if I took out an x. Now we can check it. We can check to make sure it's right, because if we multiplied that times that, we'd get a 6x squared. Now, if I divided out a 3, I'd have a 1, right? And I took out its x. And again, if you're stuck, you can always go back and say, well, if I did it right, then I should be able to, don't, just watch. You should be able to go this times this, and recreate your original problem. Okay, see what I did? 6x squared plus 3x, right? So if you're not sure if you factored it right, you can always recreate your original problem and do it. Okay, now, that's factored, right? Okay, now, there's no equal sign, so we don't need to solve. There's no equal sign, so we don't need to solve. It's just factored, okay? All right. Let's look at 15, okay? First of all, what do they have in common? What's the biggest number that divides into both? Good. 6 is right. 3 is correct, but we'll go as big as we can. Okay, 3 is not wrong. Whoever said 3 is correct. But let's take out the biggest number. Now, what else do they have in common? A u. Okay, so pull out the 6 u, right? And again, we're trying to set up these mini equations, right? Because the mini equations make it easy to solve, right? Okay, so then if I take out the 6u, so again, 6 goes into 18 how many times? 3. I took out a u. There's 4 here, but I took out 1, so how many left over? 3. So I'll go u to the, oops, that's a bad looking u. U to the third, right? Because I took out a u. 6 goes into 6 one time. All right, 6 goes into 6 one time, and I took out its u. Now again, if you aren't sure if you did it right, you can always go this times this, and check it out. 18 u to the fourth minus 6u. Okay, that's your check. Make sure you're doing it right. So first of all, how am I doing? Am I here or am I here? Okay, so factoring's not that bad, and you should have done it in algebra. I don't know if you did or not. I know 6 kids in here did do it. You do know how to factor, right? Right, Cooper? Right. You do know how to factor. All right, so now, let's go to 17. 17. They don't have a number in common, do they? There's no number. So don't worry about it. But what do they have in common?
That's 16.
16, yeah. Did what did I say? Okay, let's look at 16. So they don't have a common, you can't divide. There's no common number. Hey, Katie. But what about z's? What do they have in common with z's? How many z's do they both have in common? 6. So take out all 6. Totally right, Luke. So again, I'm going to say it. Thank you for answering. How many z's do they both at least have in common? They got 6 apiece, right? They both have at least 6 apiece. Take out all 6. Okay. So then what's left over? So the 7 is still there. I never took out the 7, right? Never took out the 7. 7's still there. I took out 6 z's. How many z's are left? So I could put a z to the 1. You don't need the 1 there. You don't need the 1, but I'll put it there just maybe. Okay, plus, I did not take out the 2, did I? 2 stays inside, but I took out all of its z's, right? Okay, so far so good? Okay, let's shift to 18. Let's shift to 18, okay? All right, one more time. So what is the biggest number? Hold on. Oh, you're doing an awesome job. Wakila. Wakila? Yep. She's on her way. Thank you. Mr. Hoy, I want to see you. All right. Okay. So, 18. What are they having? What's the biggest number that divides into both? What's the biggest number that divides in both? 5 is correct, but I think 15 actually. Doesn't 15 go in 40? 5's not wrong. 5 is not wrong, but we want to take out as much as we can. 5 is correct, but let's take out more. Let's take out 15, okay? Because I think 15 divides into 45 3 times, doesn't it? Okay, what else do they have in common? What else do they have in common? What else do they have in common? An F. They have at least one F. I mean, this only's got one. I mean, I'd like to take out more, but it's only got one F, okay? So, right? So, you ready? 15 goes into 15 one time. No, you do not need the 1. But let's put it there anyway, okay? Michael, you're going to ask it. You don't need the 1, okay? And then I took out one F. How many F's would be left over? 3. 15 goes into 45 how many times? 3. And I took out its F, okay? All right, now, all we did was factored. We didn't solve. All we did was we factored. We didn't solve. All we did was factored. We didn't solve. Now, if you take a look at question number 35, let's do 19. We'll do 19. If you look at question number 19, there's an equal sign. I'm going to highlight it. There's an equal sign. It says solve. Okay, it says solve. So if we're going to solve it, we're going to factor first, get many equations, solve our many equations. So we're going to factor. So I'm going to write this down. I'm going to factor. Then I'm going to get many equations, factor, many equations, and then we're going to solve, okay? So we're going to factor, again, many equations, and we're solve. Okay, now before we even do this problem, I'm going to help us all out. I'm going to put a 1 right here. I'm going to write a 1 right there because it's going to help me out later, okay? I'm going to put a 1 right there. Everybody put a 1 right there. It's going to help, okay? So let's factor. What do these two terms have in common? What do these two terms have in common? A k, right? Good. So if I take out the k, what's left over? 6k plus, that's why I put the 1 there. See why I put the 1 there? Because if I take out the k plus 1 equals 0. Okay, now, everybody write that down. Everybody write that down, right? Okay, everybody got that written down? If I turn the page, hey, it looks like one of these, doesn't it? Remember? Looks like one of these. So what are we going to do? Many equations and solve, right? So now we go back to here. All right, so many equations. I got k equals 0, and I got a 6k plus 1 equals 0, right? How am I doing, okay? This one's already solved for. Boom, it's done, right? K equals 0, boom, I got it. How about this one? What are we going to do to solve for k? Okay, you guys how to solve for k? What are we going to do? Minus 1, right? 6k equals negative 1, right? Divide by 6, divide by 6. So that's just either a decimal, or I like to just keep it as a fraction. I mean, negative 1/6, much easier, right? Than going how about just negative 1 divided by 6? Oh, hey, that's a fraction, right? Negative 1 divided by 6. Hey, that's a fraction. Negative 1/6, right? Okay. Let's take a look at 21. Okay? 21. We're getting close to the end. 21. What do they have in common? What do they have in common? A z, and I think of 4 also. I think 4 goes into 52. Who's got a calculator? Hey, Ben, 52 divided by 4. Tell me what it is.
It does.
13? Is it 13 or 14?
13. Wait, 50. It's 13.
Yeah, 52 divided by 4.
13.
13. So let's take out a 4, because they have a 4 in common, and a z, right? So we factor, make our mini equations, solve, right? So if I took out a 4z, what's left in this first term? What's left over? What's left over? Took out a 4z, what's left over? Just z, good. Plus, and thank goodness Ben just told us, 4 goes in 52, 13, right? We just did it on the calculator, 13, okay? Okay, mini equations, right? We factor, mini equations solve. How many kids don't need the mini equations can solve in your head? Okay, right? You can see the negative 13. You guys agree with negative 13 and 0? But let's do the mini equations anyway, because some of you are going to skip, some of you will skip this next step because you can do it in your head, okay? So if I go 4z equals 0 and z plus 13 equals 0, right? Right, we got our mini equations. We're going to solve, divide by 4, z equals 0, minus 13, z equals negative 13. How's that? Okay, I want to do 2 more, okay? Okay, I want to do 2 more for sure. Okay, so 22. What we have to do is this. We have to bring this term over so we can factor it. Okay? You got to bring that term over to factor it. You got it, because it got to be together. So how can I just pick up that negative 72x? How can I bring it over? How do I bring it over? You can add it. You hear what Luke said? So if I add 72x, it'll come over, right? Everybody agree with that? So I'm going to go 6x squared plus 72x equals 0. Nice job, Luke. Okay? There we go. Now it's together, so we can factor, right? So bring it over. So now we can factor. What do they have in common? What do x? I agree. What else do they have in common?
6.
6 and an x. Okay, right? Okay. So I would have an x plus 12 equals 0, right? Because 6 goes into 72 12 times. 6 goes into 72 12 times. My mini equations. Okay. Divide by 6, x equals 0. Minus 12, x equals negative 12. Okay. So, if they aren't together, and we won't do 23 or 24, but I just want to show you. Okay. We won't do it. I'm going to bring, in this case, the 22s this way, okay? Bring them to the s squareds. Bring them to the squareds. So I will have 0 equals 11s squared minus 22s. Okay? And I'm not going to finish it, but we'd factor mini equations, right? This one, I'll bring the 21p this way. Always bring them to the square. Always bring them over to the square. So I'd have a 7p squared minus 21p equals 0. Okay? Last one, I want to do 25. Okay? Okay, you guys okay? So you want to get them together so you can factor. You factor, get your mini equation solved, right? Get them together so you can factor. The whole goal is to factor. Once you factor, you get your mini equations. Once you get your mini equations solved, you get your answers, right? Okay, one more time, right? Get them together so you can factor. Get them together so you can factor. Factor, get your mini equations and solve, okay? 25. Looks hard. I don't think so. A boy kicks the ball in the air. The height above the ground ball is modeled by y equals 16, negative 16x squared plus 80. Okay, so let's go ahead and just draw a picture. Okay, check it out. Let's draw a picture. Ball gets kicked, hits the ground, right? There's my picture. There's my ball. Ball gets kicked, right, in the air, hits the ground. Okay, right? That makes sense, right? Kicking the ball, travels that path. Okay, now when it's right here, it hits the ground. You guys agree? Everybody agree with that? When it's right here, it's on the ground. So this is the y value of 0, isn't it? Isn't this the y value of 0? So if we set the y equal to 0, we can find out when it hits the ground. So set it equal to 0. Okay, set it equal to 0. Because